So good morning everyone and welcome to this lecture. This is electrostatics. We are beginning with electrostatics and this is electrostatics lecture 1. This electrostatics is basically part of electromagnetism. Electromagnetism is a branch where we study about electric and magnetic fields. They are same. Electric and magnetic fields are same, created from the same concept, explained by the same theory, and therefore this topic is known as electromagnetism. Electrostatics is the beginning of this chapter. And what do you mean by electrostatics? Electro means something related to charge, statics means rest. So, this is the study of charges at rest. Electrostatics is the study of charges at rest. When charges are at rest, what do they do? So electrostatics is the study of charges at rest. Now, the first thing that comes in electrostatic is the definition of an electric charge. What is an electric charge? Any idea?
No, sir.
What is an electric charge? Now, electric charge, you can think of electric charge as the property of matter due to which it experiences electrostatic or electric and magnetic effects. So, it's a property due to which a body experiences electric and magnetic effects. Electric and magnetic effects, a property by virtue of which a body experiences electric or magnetic effects. Then we must know that there are two types of charges, positive and negative. Yes or no?
Yes, sir.
Positive charges, like charges repel each other and unlike charges attract each other. Simple example, two positive charges, they will repel each other. Two negative charges, they will repel each other. One positive and one negative charge will attract each other. The SI unit, what is the SI unit of charge?
Coulomb.
SI unit is Coulomb, denoted by capital C, and that is nothing but equal to ampere second. So that becomes the dimension. The dimension becomes A into T, ampere into time. Ampere is the fundamental unit multiplied by time. That is the definition. That is the SI unit of this charge. Note it down. Let me know once you are done. Okay, then. Then we move on to the basic properties of a charge. What are the properties of a charge? Properties of charge. Properties of charge. Charge is a scalar quantity. You can add them, subtract them, just like numbers. How do you get a body charged? Every body has an atom. Atom is electrically neutral. What do you mean by when I say a body is electrically neutral? Electrically neutral body means the net charge on the body is zero. Do we understand this?
Yes, sir.
Electrically neutral body means positive charge is equal to negative charge. Electrically neutral body does not mean that the body does not have any charge. It means that the number of positive charges and the number of negative charges are equal. Proton, we say, has got a positive charge. Charge of a proton is taken as positive, and it is plus 1.6 into 10 raised to the power minus 19 Coulomb. Charge of an electron is taken as negative, minus 1.6 into 10 raised to the power minus 19 Coulomb. One is taken as positive and the other one is taken as negative. That does not mean that one is more and the other one is less. They are just different type of charges. So instead of calling them by different names, Ram or Shyam, Sita or Gita, we call them positive and negative. Positive and negative of a charge does not mean that negative charge is less and positive charge is more. It's just a sign that is given. Normally, a atom is neutral. Whatever number of protons are there in the nucleus, the same number of electrons are revolving in orbits. Electrically neutral, net charge is zero. Now you cannot take out protons from the nucleus, because if you take out protons from the nucleus, the atom changes and it becomes a different atom. The only thing that you can do is to take out electrons from the outermost orbits. Now, if you take out one electron from the orbit, one electron is less. Number of protons are more. Number of protons are same, but the number of electrons have become one less. The body or the atom will acquire a positive charge. You can call it a ion, positive ion, and it will have positive charge equal to one electron. If you take out two electrons, it will have positive charge equal to two electron, and so on. If you can add electrons in the outer shell, the number of electrons will become more, but the number of protons will remain same. The body will now acquire negative charge. If you add one electron, negative charge equal to one electron, two electron, negative charge equal to two electron, and so on. That means charge is transferable. You can transfer charge from one atom to the other atom, from one body to the other body. Charge is transferable. You can transfer charge from one body to the other body. That is the next property. Charge is conserved, and that's a very important property that you must remember. The total charge of the universe is always conserved. Charge of an isolated body is always conserved. When I say isolated body, if you have a body which is not attached to anything, any conductor, any body which is not attached to anything, the charge of that body or that conductor will remain constant. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Note down these points. These are very important points. That takes us to the next property. We already know charge is of two types, positive and negative. Proton is supposed to have positive charge and electron is supposed to have negative charge. You can charge the body by transferring the electron from one body to the other body. We understand this? Yes or no? No, yes. Charge is of two types. Then the next point, and a very important point, charge is quantized. Now, what do you mean by charge is quantized? Charge only exists in package. Charge always exists in packets. And what is the smallest packet of charge? The smallest packet of charge is the charge of an electron or charge of a proton. You can only give one or two or five or 10 or 1,000 or 10,000 electrons. You cannot give half or one third of an electron. Therefore, charge is quantized. Now, do we understand this? Charge exists in package. Do we understand this?
Yes, sir.
We have postulated the existence of quarks. In fact, we know that quarks exist, and these quarks, they are a particle which have fractional unit of charge 1 by 3 and 2 by 3 times of E, but these quarks do not have independent existence and they have a very short span of time, and therefore we do not take it as a fundamental packet of charge. We always assume that charge is only by the transfer of electrons and not by quarks, and quarks do not have an independent existence. So charge is quantized. Do we understand this? Yes or no? No, yes.
Yes, sir.
Next one, I can write one more, then you can note this down. Charge is always associated with mass. You cannot have a charge without a mass, but you can have a mass without a charge. Neutron is a body, is a particle that has mass, but it does not have charge. But whatever body has a charge must have a mass, because this charge comes from electron, this charge comes from protons and electrons have mass. So charge is always associated with mass. Do we understand this?
Yes.
I'll give you 2 minutes to note this down. That takes us to the next set of properties. Listen to me carefully, then I will give you time to write. Charge is relativistically invariant. It means that the value of charge is independent of the frame of reference, or the value of charge does not depend on its speed. You must remember that the mass of a body depends on speed. If you go near to the speed of light, your mass changes, length changes. But the value of charge, no matter from where you see it or no matter what speed it is moving, the value of charge of an electron will always remain the charge of an electron, no matter what speed it is moving. Do we understand this?
Yes, sir.
A charge at rest, which is we are studying now, produces only electrostatic field or electric field. It's better to call it electrostatic field. Charge at rest, you can see here, it only produces electrostatic field. If the charge is moving with a uniform velocity, that would be the next chapter, magnetism. It produces both electric or electrostatic and magnetic field. If a charge is moving with an acceleration, it also gives electromagnetic waves or energy. That is the last chapter of this, EM waves. Do we understand this?
Yes, sir.
And this is the topic that we are going to study at the end of this chapter, electrostatic. If a charge is given to an isolated conductor, it will always reside on the outer surface of the conductor. There is a conductor, you give it charge, that charge will always come on the outer surface. But the charge density, charge per unit area, may not be uniform. In fact, charge per unit area is inversely proportional to the radius of curvature. Sharp edges will have more charge and blunt edges will have less charge, and therefore if there is a sharp edge, charge, since the concentration is more, it can leak. We call it electrostatic discharge. We will get to know more about this properties of charge and the properties of conductor. Right now, just note them down. I'll give you 2 minutes to note it. This is what I was telling you. If the radius of curvature, let us say a sphere, is uniform, charge will be uniformly distributed. If it is non-uniform, sharp edges will have more charge and blunt edges will have less charge. We understand this? Yes or no?
Yes, sir.
Okay, I'll give you 2 minutes to note it down. That takes us to this table. There is a comparison between charge and mass. Why this table is important? Because any mass we have dealt it in this chapter of gravitation. Mass creates gravitational field, experiences gravitational force, charge creates electrostatic field and creates electrostatic field and experiences electrostatic force. Electric charge is of two types, positive, negative. It may be zero as well. Mass is always positive. Therefore, gravitational field was only in one direction. Electrostatic field and electrostatic force can be attractive as well as repulsive. Charge does not depend on velocity or speed. Mass depends on this speed. We remember this relation, yes or no?
Yes, sir.
Mass, charge is quantized. Mass quantization, still we are working on it. The Higgs boson particle, probably the particle that gives everyone its mass. Electric charge is always conserved. Mass can be converted into energy is equal to mc square. Electric force can be attractive or repulsive. Gravitational force is always attractive. We understand this? I'll give you 2 minutes to note this down. Let's move ahead. First question. A soap bubble is given negative charge. Its radius will increase, decrease, remain unchanged. The radius will increase, and the reason is because of repulsion between negative charge. When you give it on a bubble, there will be repulsion between the negative charge, and that is why the radius will increase, not because of mass increasing. Next question. Which of the following values of charge is not possible?
Fraction.
Yes, because of quantization of charge, 1 by 10 time charge of an electron is not possible. Only integer multiples are possible. Next question. I'm putting all these questions in one screen only because they are small questions. Next one. 5 ball numbers 1 to 5 are suspended using separate threads. Pair 1 2, 2 4 and 4 1 show attraction. 2 3 and 4 5 show repulsion. Ball 1 must be what? Yes, why it is neutral?
Sir.
Why it is neutral? Remember, repulsion is a sure shot test of charge. Repulsion is a sure test of charge of a body. If a body has a charge, the only way you can find out whether it has a charge or not is by repulsion. Attraction is not a test for having a charge. A neutral body, and we will see that if you bring a charged body near to a neutral body, this charged body can attract the neutral body, yes or no?
Yes, sir.
But this charged body cannot attract another body which has the same charge, yes or no?
Yes, sir.
Repulsion is a sure shot test of having a charge. 2 and 3, 4 and 5, they definitely have charge. That means either one has charge or one does not have charge. One is attracting 2 and one is also attracting 4. And 2 or 4 are attracting themselves. That means 2 and 4 must have opposite charge. But one is attracting 2 as well as one is attracting 4. That means it cannot have any charge and therefore it is chargeless. Not chargeless, it is neutral. Yes or no? We understand this?
Yes, sir.
We understand this?
Yes, sir.
Next one. Both of them will hold equal charge because charge is on the surface and their surface area is same. because the radius are same. Do we understand this? Yes or no? Next question coming on your screens. Answer is 6.25 into 10 raised to the power 18. How did you get it? Total charge is 1 coulomb. So you can write it like this. Q total charge is equal to N times E. So number of electrons will be Q divided by E. 1 coulomb divided by the charge of 1 electron. Yes or no?
Yes, sir.
Next one. Do it fast. Such type of question can come. A copper sphere contains 2 into 10 raised to the power 22 atoms. The charge on the nucleus of each atom is 29 E. What fraction of electron must be removed for the sphere to give it a charge of 2 coulombs? I'll give you 1 minute to note this down. I don't understand what you have said. What fraction should be removed? What fraction? How can a fraction be more than 1? Your answer is 10 raised to the power 22 or 18. Fraction has to be less than 1. Yes or no? 1 by 2, 1 by 3, 1 by 10. Fraction has to be less than 1. Do we understand this?
Yes.
Fraction cannot be more than 1. Your answer is, I don't know what. So it cannot be the right answer. I'll give you 2 more minutes. What is the problem in this question? Tell me. What is that you don't understand? You have to give it a charge of plus 2 microcoulomb. So how much electrons you will have to remove? Yes, tell me that. How will you find out? Number of electrons that has to be removed. Total charge is 2 mic. Just now I gave you a question. The same question, in a different way. Yes. You have to give it a charge of plus 2 microcoulomb. What is the number of electrons you have to remove? Tell me.
N equals to 2 into 10 to the power of minus 6 by
2 into 10 raised to the power of minus 6 divided by
0.6 into the power of minus 19.
1.6 into 10 raised to the power minus 19. This is the number of electrons you have to remove. You have to find a fraction. So you just have to find total number of electrons. N divided by total number of electrons is a fraction. What is the total number of electrons? Is it such a difficult question? Huh? Total number of electrons? What is the total number of electrons? This has got nothing to do with physics. This is maths. A sphere has itna atom. I'll give it for the third standard student. He will tell me the answer. My kid is in second standard. He will tell me the answer. One sphere has itna atom. Charge on one sphere is itna. Charge on one nucleus is itna. What is the total charge? You cannot find out the total charge.
29 into 2 into
Yes, that's it. And then you find the fraction. We're done. Do we understand this?
yes, sir.
It was not. See, you have to understand the language of the question. So, remember, you have to do it fast. Now, you don't have to divide it actually. You don't have to divide it actually. The total number of electrons that you have to remove is N by E. Right?
Yes, sir.
And the total number of electrons is
5.8 into
29 into 2 into 10 raised to the power of 22. Yes or no?
yes, sir.
That's it. You just divide the 2 and you get your answer. So the fraction would be 2 into 10 raised to the power minus 6 divided by 1.6 into 10 raised to the power of minus 19 multiplied by 29 into 2 into 10 raised to the power of 22. That is the fraction we are looking at. Do we understand this?
Yes, sir.
Do it this way. These are simple questions. Questions which will come once in a lifetime. If they come, you have to solve them. I hope you understand this.
Yes, sir.
Okay, one more, since you could not do this. This question has come in a lot of exams in different ways, and I hope that you can give me an answer. Take your time, take a deep breath. I need a correct answer for this one. 1 gram of solid. There are 10 into 10 raised to the power 21 atoms. If an electron is removed from every one of 0.01% of the solid, the charge gained by the solid is. We understand this question?
Yes, sir.
I await the answer. That is the correct answer. Plus 0.08 Coulomb. How you are supposed to get this? You have to find the total charge is n times charge of an electron. You already know the charge of an electron. You just have to find out the value of n. 0.01% of this much atoms. Yes or no?
Yes, sir.
When one electron is removed, remember that this could have been 3 electrons are removed, so you have to multiply it by this. So number of electrons would be, or number of electrons that are removed is 5 into 10 raised to the power 21 multiplied by 0.01 divided by 100. Yes or no?
Yes, sir.
So that will give you a number of electrons. You just multiply it by the charge and you will get, since electrons are removed, it would be a positive charge, and that is our answer. Do we understand this? Yes or no? No or yes?
Yes, sir.
Okay, well done. This is the beginning of electric charge. We have seen the properties of electric charge. Let us now move ahead and see how a body can be charged. How can you charge a body? So the next heading that we are going to write is charging a body. How can you charge a body? Number one is by friction. What happens in this friction? Bodies are rubbed together. Because of the energy, some electrons may get transferred from the first body to the second body and so on. The two bodies will get equal and opposite charge. Yes or no?
Yes, sir.
So that is how you can charge a body. You don't have to write much. You just have to understand what is charging by rubbing. So initially both the bodies are neutral. After rubbing, one gets positive charge, one gets negative charge. Remember, the total charge should remain constant. So total charge before charging was 0. Net charge, not total charge, net charge after charging is also 0. So whatever positive charge one body gets, the other body gets the negative charge. Do we understand this? Yes or no? No, yes.
Yes, sir.
I'll give you 1 minute to note it down. So now the next thing is charging by conduction. Charging by conduction. Now what happens in charging by conduction? What happens in charging by conduction? Two bodies are brought in contact with each other. One of them must be charged. Remember, one of the bodies must be charged. If the two bodies are neutral, nothing will happen. One of the bodies must be charged. Then if you bring a charged body in contact with an uncharged body, what will happen? Electrons will get transferred from one body to other. This process of charging a body by contact is known as charging by conduction. Do we understand this? Yes or no? No, yes.
Yes, sir.
I will show you a snapshot of how it looks in two different ways. This is just for your understanding. You may draw it, you may not draw it. This is just for your understanding. I'm just making it smaller. I need to put in one more picture. Do we understand this?
Yes, sir.
It could be done this way or it could be done in this way also. Instead of putting them like this, I can do it this way also. Let's make it smaller. You understand this now? What is happening here?
Yes, sir.
Just for your understanding, you don't have to draw it. You just have to understand what is happening here. And then you get the point. The second thing is like this. Instead of getting that conductors physically in contact like this, you can put a switch. Do we understand this? Huh?
Yes, sir.
Okay. Then how does this happen? The charged body will transfer some electrons, which will be or take some electrons from the uncharged body. Yes or no? There
Yes.
would be a transfer of charges. Remember, the net charge will remain constant. Do we understand this?
Yes, sir.
Net charge will remain constant. Charge will flow, and from where to where charges flow, we will see that also. We will see that also. When time comes, we will see that also. Right now, what you can understand is charge is going to flow from one body to the other body, and because of this, the bodies are going to get charged. And remember, the net charge will remain constant. That is the first point. Net charge will remain constant. Do we understand this?
Yes, sir.
Net charge will remain constant. The bodies will get charged because of transfer. This transfer can happen by the transfer of electrons. Electrons will always flow from a point of lower potential to a point of higher potential. I'll give you 1 minute to note this down. Let us move ahead and move into the next thing. Now, in this process of charging by conduction, one of the body must be charged, and we have to bring it physically in contact with the other body. The third type of method of charging is by induction. And in this process, we don't have to bring the bodies in contact. We can just bring it close enough, and that is why it is said that repulsion is a sure shot test of charge, not attraction. If a charged body is brought near to an uncharged body, and I will show you with this example also so that you understand. This one is good or this one is good? And this one is good. Which diagram is better? So, if I bring a charged body near to an uncharged body like this, a positively charged body is brought near a neutral body which is there. Now, because of this, what will happen? Negative charges will come on this side and positive charges will go on the other side. Yes or no?
Yes, sir.
In the second process, what I have done is I have earthed this body. When I earth this body, what happens? Whatever positive charges are there on this side will go to earth. Yes or no?
Yes, sir.
Then I remove the earthing, the body will have only negative charge. If I remove the charging body, the body still has a negative charge around it. Do we understand how this body is charged?
Yes, sir.
And you must understand that I have not brought these bodies in contact. Yes or no? No or yes?
Yes, sir.
What are the important points that you must remember? Point number one, the body which is inducing the charge does not gain or lose electrons. Yes or no?
Yes, sir.
Then the charge which is induced on the other body will be opposite to that of the inducing body. Yes or no? No or yes?
Yes, sir.
This type of induction can only happen in bodies and not in point masses or charges. With a very small point particles, this type of charging will not work. Do we understand this?
Yes, sir.
I'll give you 2 minutes to note this down. Okay, then we move ahead. And I'll give you one more question here. I've seen this question. This one. 10 raised to the power 12 alpha particles, helium of nuclei per second falls on a neutral sphere. Calculate the time in which the sphere gets charged by 2 microcoulomb. I'll give you 2 minutes to do this. 6.25 seconds. How are you getting 6.25 seconds? That is correct.
Sir, I have taken uh, total charge equals to charge per unit time into time.
So, if I say that the time is t seconds, so total charge falling per second n multiplied by t, that should be equal to total charge q. Total charge falling per second is how much? 10 raised to the power 12 alpha particles, and every alpha particle has got 2 times the charge of an electron. Yes or no?
Yes, sir.
Multiplied by time, that must give you 2 into 10 raised to the power minus 6 coulomb. You divide, multiply, and you get your answers. Everyone understands this? Yes or no?
Yes, sir.
Well, that's good. Let us now move on to the next heading of this chapter. And the next heading is the most important one, Coulomb's law. Coulomb's law. What do you mean by Coulomb's law? Yes, we must be knowing it. What do you understand by Coulomb's law?
Force between two charges is directly proportional to product of their charges and inversely proportional to square of their distance between them.
That is correct. So, if you have two charges which are separated by each other, they will exert forces on each other. If I have two charges, let us say Q1 and Q2, separated by each other by a distance r, then it has been found that the force between these two charges is directly proportional to the charges and inversely proportional to the square of distance between them. or I can write this as K Q1 Q2 divided by R square. K Q1 Q2. First let me explain it, then I'll give you time to write it. K Q1 Q2 by R square, where K is a constant. K is a constant. K is a constant, and it depends on the medium between the two particles. K is a constant and it depends on medium between the two particles. Do we understand this?
Yes, yes.
K for vacuum. The value of K for vacuum can be written as 1 by 4 pi epsilon naught, and that becomes equal to 9 into 10 raised to the power 9 Newton meter square per Coulomb square. Newton meter square plus Coulomb square. This epsilon naught, have you heard about this term epsilon naught?
Yes, sir.
This epsilon naught is known as absolute permittivity of space, of free space, and the value is 8.85 into 10 raised to the power minus 12. And remember its unit and dimension 10 raised to the power minus 12 Coulomb square per meter square. Coulomb square plus Newton meter square. The dimension of this thing is m L minus 3 T4 and A square. Do not forget this anywhere, anytime. Do we understand this?
Yes, sir.
Then there is one more term that will come, not here, but in the next chapter. Absolute permittivity. Chalo, we will see that there. Do we understand this much?
Sir.
I'll give you 1 minute to note this down. Now, this is the value of K in vacuum, but sometimes there may not be vacuum. So, if it is not in vacuum, then we write the value of K as 1 by 4 pi epsilon, where epsilon is known as the permittivity of the medium. And the value of this epsilon can be written as epsilon naught into epsilon r, where epsilon r is known as the relative permittivity of the medium. Do we understand this? This relative permittivity of the medium is also known by a different name, K. Have you heard this name, K? Dielectric constant. Dielectric constant. Do we understand this? The value of this K varies from bodies to bodies. The value of this K varies from bodies to bodies. For conductors, we will see in capacitance, for conductors or metals, the value of K or epsilon r is infinity, and it always lies between 1 to infinity. The value of K for vacuum is taken as 1. I'll give you 2 minutes to note this down. Now, since we have seen this form, now is 1 by 4 pi epsilon K, the value of K as 1 by 4 pi epsilon is valid when the medium is completely filling up the space. So, if this is the case, then the formula is valid. If this is the condition, then the force in the medium becomes force in air divided by K. That means it becomes 1 by 4 pi epsilon naught K into Q1 Q2 by R square. That is the formula that we have written. Epsilon naught into K is written as epsilon. Epsilon. Do we understand this?
Yes, sir.
But sometimes, and I have seen one particular question, you never know what this can come. Sometimes we might have a condition of this nature where it is not completely filling but it is partly filling. When it is not completely filling but partly filling, it is filling only up till a distance of t, and the rest part is vacuum or air. In this case, the force between the particles, in this case, the force between the particles will be given by this formula, 1 by 4 pi epsilon naught q1 q2 upon, and remember this formula you will not find it in books, r minus t plus t times root over k whole squared. Okay,
Okay, sir.
note this down. Well, then let's move ahead. What we have seen is the formula of force, and let us just write it like this: K Q1 Q2 by R square. This is the formula for electrostatic force that we have seen. Yes or no?
Yes.
Now, you must remember what type of quantity is force. What type of quantity is force? Scalar or vector?
Vector, sir.
But this is the scalar formula of force. That means it will only give you the magnitude of force. It will only give you the magnitude of force. Now remember, it only gives you the magnitude of force. That means whether the charge is positive. If the charge is positive, you will obviously put the positive values. If the both charges are negative, even if you put both negative values, you will get the answer as positive. If one charge is positive and one charge is negative, then should you put positive value here or negative value here? Remember, positive and negative value only means that they are different charges. In this formula, whether the charge is positive or whether the charge is negative, you will only write the positive values because you are only getting the magnitude of the force. Do we understand this?
Yes, sir.
How will I get the direction? Because force is a vector quantity. How will I get the direction? So you'll have to find out some way of getting the direction. How do I get the direction of force? Hmm? 2 point charges, Q1 and Q2. How will I get the direction of force between these two charges? Hmm? The direction of force The direction of force between the two charges is along the line joining the two charge. Along the line joining the two charges. It's along the line joining the two charges. Then, if both the charges are positive, then the force would be repulsive. So force would be like this. If both the charges are negative, then also the force would be like this. But if one charge is positive and the other charge is negative, then what happens? Then the force would be attractive. So this is how you can find the direction of force between two point charges. It is always along the line joining the two charges. If the charges are like, the force would be repulsive. If the charges are unlike, the force would be attractive, and this is how you find out the direction. Do we understand this, everyone?
Yes, sir.
This is the scalar formula of force. You get the magnitude from the formula, it has to be always positive. Then you get direction using the things that I have shown to you, line joining the two charges. This is the formula that we are going to use in 99.99% of cases. But there could be 0.01% of the cases where we might have to use the vector formula. What is the vector formula of force between two charges? And please be attentive. I will give you time after this to note this down. First listen to me, then you will note this down. Now let me go back. This charge is q1, and whatever formula I'm writing it in vacuum. I will write it as k. The value of k in vacuum will be different, and the value of k in medium would be different. We understand this, yes or no?
Yes, sir.
Let us say the charges are q1 and q2. This is the line joining the two charges. Now let us assume that the force charges are positive, so that it is easier for me to draw them. They are separated by distance r, let us say. Now I have to make a vector formula for this. Will these two charges experience attraction or repulsion?
Repulsion, sir.
So the forces on this would be directed like this, yes or no? Let me call this force as F vector wise 1 2. This force as F vector wise 2 1. What is F12 and what is F21?
Force on
F12 is the force on 1 due to 2, and F21 is the force on 2 due to 1. You understand this?
yes, sir.
That's it. How do I write F21? F21 vectorly can be written as k times q1 q2 divided by r21. When I write r21, it only means the magnitude. Do we understand this? R21 squared multiplied by unit vector R21. You understand the meaning of unit vector R21?
Yes, sir.
It's a vector directed from 1 to 2 divided by the vector itself. Do we understand this?
Yes, sir.
Whatever is written here, do we understand what I have written here?
Yes, sir.
Or shall I need to explain it?
No, sir.
Pakka, sir?
Yes, sir.
Now, here I have created first let me speak. I will give you time to write. First, here I have created the vector form. It will give you both the magnitude as well as the direction of force. Do we understand this?
Yes, sir.
It will give you both the magnitude and direction of force. This is the vector form. It will give you both the magnitude and the direction of force. But here you will have to put the charges with their signs. If both are positive, it's positive. Force will be in this direction. If both are negative, the force will again be repulsive in the same direction. If one is positive and other is negative, you have to put them with signs. If one is positive and other is negative, force will become reversed. Do we understand this?
Yes, sir.
Similarly, I can write F12 vectors. Can you tell me how will be F12 vector written?
Into Q1 Q2 by R12. Oh, sorry.
Divided by R12 square multiplied by R12 unit vector. Do we understand this?
Yes, sir.
Now instead of writing R12 unit vector, you can write R vector divided by the magnitude of R12 vector. So instead of square in the denominator, you will have cube in the denominator. Do we understand this?
Yes.
I am not going to go much into this. This R hat unit vector can be written as R vector to 1 divided by magnitude of R divided by the magnitude of R to 1. You can put that value and then you can write the answer in that form. Also, I'll give you 2 minutes to do that. You can do this on your own, yes or no?
Yes, sir.
Do it. Now, there are some important points that you must remember about these formulae that I have written, whether it is the scalar form or is the vector form. Remember this formula that we have written, it is only applicable for point charges, assuming that the charges are point charges, or if they are bigger bodies, the distance between the bigger bodies should be very less compared to the distance between them, so that they can be taken as point charges. If it is a rod, if it is a other shaped body, the force cannot be calculated by this formula. Do we understand this?
Yes, sir.
First, let me say, then I will give you time to write. The next point is this force that is between the 2 point charges. It is equal and opposite. Action reaction force, whatever force one charge exerts on the other charge, the second charge will also exert the same force but in the opposite direction. Action reaction force. Do we understand this?
Yes.
This electrostatic force is a conservative force. We have already dealt with conservative force. Yes or no?
Yes, sir.
This force is also a central force. When I say central force, that means it depends. I mean, the force is directed along the line joining the two charges. Yes or no?
Yes.
Remember, this force is inversely proportional to 1 by r square. I have already told you that. Yes or no? This force depends on the medium between the particle. I have told you that. Yes or no? These are some of the points that you must remember about this force. Do we understand this?
Understood, sir.
Pakka, sir.
Yes, sir.
No doubt on that, sir.
Yes, sir.
I'll give you 5 minutes, sir, to note this down, sir. So the next heading, and the next heading is principle of superposition. We have done that before also. Do we remember this?
Yes, sir.
Where we have done this?
Waves, sir. Mm,
Apart from waves?
apart from waves, gravitation.
Apart from waves, gravitation. Whether it was in waves or it was in gravitation, the question remains the same. If we have more than one force acting on a charged particle, on a charge, it is valid for all types of vectors. So the net force on the charge will be the vector sum of all the forces. This principle is known as the principle of superposition. Do we understand this?
Yes, sir.
Do we understand this? Yes or no?
Yes, sir.
I will give you 2 minutes to note this down. Let us now move ahead with some questions. And this is the first question that is going to come. Remember, these are the questions that are coming these days, and maybe 5 days from now, you will find one of these questions in your one of the attempts. If the distance between two equal point charges is doubled and their individual charges are also doubled, what will happen to the force between them?
Remains same, sir.
Why it remains same?
Sir, mm, force is directly proportional to product of charges.
Right?
So individual charges are double. So that is 4 times. And
Okay. So you understand how it is done? Yes or no?
yes, sir.
Okay, let me take you to the next question. This one. And I will put it here only. Next question. 2 point charges, 3 microcoulomb and 8 microcoulomb repel each other with a force of 40 newtons. If a charge of minus 5 microcoulomb is added to each of them, then the force will become, I'll give you 2 minutes. Minus 10 Newton. How did you get it? So, initially the force between them, remember the only formula of force that we are using is K Q1 Q2 by R square. If I write in the initial sense, force between them is K by R square into 3 multiplied by 5, whatever it is.
Multiplied by 8, sir.
Oh, 3 multiplied by 8, sir. If a charge of minus 5 is added, so charge of minus 5 is added, the next force F dash becomes K by R square. The charge on one body will become minus 2 microcoulomb in the negative, multiplied by 3 microcoulomb. Yes or no?
Yes,
So
sir.
the force will become 1 by 4 times, and it will change its sign because now it will become
Attractive force.
attractive in nature. Do we understand this?
Yes, sir.
Next one. Two charges, 40 microcoulomb and minus 20 microcoulomb are placed at a distance apart. They are touched and kept at the same distance. What is the ratio of the initial and the final forces? The question is pretty simple. Two charges, 40 microcoulomb and minus 20 microcoulomb, are at a certain distance apart. They are touched and kept at same distance. What is the ratio of forces? I'll give you 2 minutes. The answer is 8 is to 1. Remember, force is given by the formula K by R square multiplied by Q1, Q2. K and R are same. Q1 in first case is 40 and the second charge is 20. Forget about plus and minus. So the net force will be 800 or 80 something. Now when they are touched, what happens is charges interchange. The net charge will remain same for both the spheres or what the charges are of the same dimension. So the net charge is plus 20 microcoulomb. Yes or no?
Yes, sir.
So the charge will be equally distributed because there is nothing else given. So 10 microcoulomb and 10 microcoulomb will come. The net force will become 10 into 10, 10 into 10, 100. Initially it was 800. So the answer is 8 is to 1. We understand this? Yes or no? No, yes.
Yes, sir.
The next question is a question, but once you solve it, you will remember it as a concept so that you don't have to solve it again. A total charge Q, I think we have done it in gravitation also, is broken into two parts, Q1 and Q2, and placed at a distance r. When will be the maximum force or repulsion exist between them? Do you remember this question? Well, we have to understand and remember things. We can't understand things. We'll have to remember them. The answer is this. It has to be half. I've done it in gravitation also. This is the electrostatic version of the same. So remember the answer for this particular case is half. The force is maximum when the charge is half. We have done it in gravitation also. Let us move on to the next question. And the next question is this. Two charges equal in magnitude and opposite in polarity are placed at a certain distance apart and force acting between them is F. 75% of the charge of one is transferred to the other. Then the force between them is how much? F by 16 is the correct answer. I mean, just have to see the diagrams. I'll just show you a diagram so that I'll save some time. This is the initial case. Plus Q minus Q. This is the final case. 75% of the charge has been transferred. So the positive charge becomes plus Q by 4 and the negative charge becomes minus Q by 4. And the answer is F by 16. Do we understand this or this has gone above our head saying bye bye?
Understood, sir.
Thank God, sir. God is great, sir. Let me move on to the next question. Again, we have done the same question in gravitation, but we have forgotten it. That is why I did not do electrostatic just after gravitation, because I knew that you will forget. A particle of mass m charge q1 is revolving around a fixed charge minus q2 in a circular orbit of radius r. Calculate the time period and the speed.
Q2 by M into R.
Speed is
Under root K Q1 Q2 by M into R.
correct. So basically what you got to do, I even don't have to draw the diagram. The electrostatic force of attraction between the two, F electrostatic, must provide it with the centripetal force K Q1 Q2 divided by R square should be equal to M V square by R. From there you should be able to calculate the values. Yes or no?
Yes, sir.
Chalo. We move ahead to this question. As I said, in 99.99% of the cases, something happens. In 0.01% of the cases, something happens. This is the question from that 0.01% of cases. Question is given. You have to find FA vector and F2 vector. You can give your answer in terms of K, Q1, Q2, and everything else. Don't have to actually calculate the value. You can give me K, Q1, Q2 in that sense. So basically, what you got to do, if I have to find force on particle A due to particle B, K into Q1, Q2 divided by R square, distance square. You can find out the distance, that is 25, yes or no?
Yes, sir.
Into unit vector RAB. How will I find the unit vector RAB?
Sir, that is.
It's a vector drawn from B to A.
Yes,
So
sir.
vector A minus vector B. So it will become minus 3I minus 4J divided by the magnitude is 5. So that is the answer that I was looking at. Do we understand this, or this has gone above our head saying bye bye?
Understood, sir.
That is the answer that I was looking at. 1% of the cases, and this is the answer for that 1% of the cases. Shall we move ahead?
Yes, sir.
This is the next question. 3 equal charges plus q each are placed at the corners of an equilateral triangle of side A. What will be the force on any of the charge? That is correct. I think we have done this question before also. It's a very simple question. Force between all the particles is same, yes or no?
Yes, sir.
That will be equal to K Q square by A square. Then you have two forces inclined at an angle of 60 degrees to each other, yes or no?
Yes, sir.
Inclined at an angle of 60 degrees with each other. You can use the formula F is equal to under root of F1 square plus F2 square plus 2 times root over F1 F2, yes or no?
Yes, sir.
And from there you will end up with this formula. Do we understand this?
Yes, sir.
3 equal point charges of charge plus q each are moving along the circle of a radius r. The point charge minus 2q is also placed at the center of the circle as shown in the figure. Since it is given as shown in the figure, I'm entitled to show you the figure. The charges are revolving with constant and same speed in the circle. Calculate the speed. So, how are we supposed to do this? If I can just take the diagram from here so that it becomes simpler for me to solve the question. Okay, so you see the diagram here, right?
Yes, sir.
This charge, the pink charge, is exerting a force like this, and this charge, the green charge, is exerting the force like this. Both the forces are same in magnitude but opposite in direction, inclined at an angle of 30 degrees from each other. Yes or no? Inclined at an angle of 60 degrees. We have just now calculated this force. The radius, the equilateral triangle will have the equilateral triangle will have the will have the will have the length as root 3r. Yes or no?
Yes, sir.
So you can calculate this net force. This net force will go like this in this direction. Yes or no?
Yes, sir.
This force minus this yellow force will give you mv square by r. Yes or no?
Yes, sir.
That's it. How much is the yellow force?
Sir,
How much is the yellow force? K into q into 2q divided by r square. Yes or no?
yes, sir.
How much is the summation of green and orange for pink force? You just now calculated it. How much is that?
Root 3 r square, square by 3r.
Take deep breaths and then give me the answer. The distance is root 3. Remember that. Okay. So just put root 3 in your answer there and you will get. Yes. How much? K into q square into root 3 divided by 3r square. Yes or no?
Yes, sir.
That should be equal to mv square by r. Once you calculate this, you will get v as what is the answer given. I will just note down that answer. K q square by r m 2 minus 1 by root 3. Are we getting this answer?
Sir, M is not given, no, sir.
M must be given. Maybe a mistake. Do we understand this?
Yes,
M
sir.
is always given in such cases. Do we understand this?
Yes, sir.
Got this answer? Shall I move ahead in life?
Yes, sir.
Next question, and I hope that I can get a quick answer. Give you 2 minutes. Well, it will be same as 2 into 10 raised to the power 5 Newton. Do we understand how it is done?
Yes, sir.
Initially, the two spheres were like this. They were having equal charges, yes or no?
Yes, sir.
And finally, when you bring a third sphere, after touching it from the second sphere, the condition look like this.
Yes, sir.
Once you apply the formula for both the cases, the answer is going to come. The answer on the sphere at the center is going to come same. Is it coming same? Yes or no?
Yes, sir.
Along which direction it is coming?
Sir,
Which direction?
it is from C to A, sir. Sorry, C to B, sir.
C to B direction. That is correct. Everyone understands this, yes or no?
Yes, sir.
This is the next question. Equal charges Q are placed at four corners A, B, C, D of a square of length A. The magnitude of force on the charge at B. It's a very important question, comes in exam many times. Option C, sir, is the correct answer, sir. How are we supposed to do it, sir? I'll take the help of this diagram so that I can do the question quickly. As you can see, three forces are acting here. The pink force, which is like this, yes or no?
Yes, sir.
Then there is one more pink force which is coming. Why I'm calling them pink forces? Because they are same in magnitude, yes or no?
Yes, sir.
It will be k q1 q2 kq square by a square, yes or no?
Yes, sir.
Both the forces are at a 90 degrees, so the and equal, so the resultant will come like this, FAC. That will be root 2 times of that one, yes or no?
Yes, sir.
Then there will be one more green force which is coming from here, and also it will go in the same direction. That will be equal to kq square by root 2a whole square, yes or no?
Yes, sir.
If you add up things properly, I think this is the answer that you are going to get, yes or no?
Yes, sir.
Everyone understand this, or this has gone above our head saying bye bye?
Understood, sir.
This is one question. Just remember it as a concept. Now, whenever they ask you the maximum force, what you got to do to find out the maximum force is you will have to find out the force as a as a function of x, and then you will have to differentiate it. Do we understand what I'm telling you?
Yes, sir.
Right? Now, here what I have is 2 point charges equal in magnitude. You just remember it as a concept. Plus q. This is the perpendicular bisector. Distance is d by 2. They're asking you to find out the point where it is where the maximum force exists on the perpendicular bisector. Do we understand this?
Yes, sir.
So whether it is here or here, there will be 2 points where this force will be maximum. You can write this distance as x, find out the net force and differentiate it with respect to x, and you will get the final answer. Forget about this. The answer in this case, if this question comes, the answer is d by 2 root 2. So just draw the diagram and write the answer as d by root 2. You understand what I'm saying here? There is no point of doing the entire derivative because it will take a lot of time. And you must understand one thing, that time is a luxury that we don't have. Yes or no?
Yes.
So you can just note it down where the force is maximum, because if this question come, it will come as a photocopy of this. Noted this down?
One.
Okay, let me know once you are done. That takes us to the next question, sir. This question has come in JEE, and I think we have also solved it in gravitation. Yes or no?
Yes.
Just to remind you, the diagram looks like this. What is the force on the charge at the center? What is the answer?
Sir, that is K Q square B, sir.
Take a deep breath. Deep breath. The deepest breath possible in this universe, and then give me the answer. Yes, what is the answer? The answer is kq square by L square, and I will not explain how it comes. I hope you understand this.
Sir, but the distance is not L, no, sir.
Take a deep breath and think. Take a deep breath. Have you taken a deep breath?
Yes, sir.
Did you get the answer then?
Sir, here in this case, the force will be the positive charge at that empty point and this minus q, no, sir.
What's the problem? Is there any problem?
Sir, I'm asking that we do, if we put a positive charge at that empty point, the q will be in equilibrium, no, sir.
Yes.
Minus q, that's charge at that point.
Yes.
So the distance between them is root 2 L, no, sir.
Have you taken a deep breath?
Yes, sir.
Close your eyes. Now open it again and look at the diagram and tell me the answer. Did you get the answer? Okay. If you did not get the answer, think about it when you go back home. We have to move ahead in life and we have to move on to the next point, which is equilibrium. Equilibrium of a charge. Equilibrium of a charge. What do you mean by equilibrium? When do we say a body is in equilibrium or a charge is in equilibrium?
Force acting them or net external force acting them is zero.
Force acting is zero. The charge is said to be in equilibrium. Yes or no?
Yes, sir.
Equilibrium. Three types of equilibrium. Anyone remembers it? Do you remember it? Three types of equilibrium.
Yes, sir.
What are those?
Mechanical equilibrium,
Yes.
mechanical equilibrium,
Keep on saying I'm listening. Are you saying something? I can't hear you. Saying something?
no, sir.
Okay. What are the three types of equilibrium? Any idea?
One is mechanical equilibrium, sir.
One is mechanical equilibrium. Another is chemical equilibrium. Third one is thermal equilibrium. Yes or no?
No.
There's only one thing that you have to forget. You know what you have to forget? There's only one thing that you need to forget. And what is that?
Habit of forgetting things.
Habit of forgetting. And that is the only thing that you don't forget because it's the habit of forgetting things. Anyways, I had idea that you will forget, so I am not surprised. I would have been surprised if you would have remembered it. That would have surprised me. Oh, you remember it. That was surprising. Forgetting is definitely not surprising. Three types of equilibrium: stable, unstable, and neutral. In stable equilibrium or unstable or neutral equilibrium, force is zero, du by dx is zero. In stable equilibrium, if you remove it from that position, it will try to come back to its original position. d2y by dx square is positive, energy is minimum. Unstable equilibrium, d2u by dx square is negative, potential energy is maximum. In neutral equilibrium, d2y u by dy square is zero. That is, energy is constant. Give you 2 minutes to again note it down. Then we move ahead in life. We have to always move ahead in life. How will you find out whether? How will you find out whether a system, what type of equilibrium is this? You know this. Now we can see the different types of cases where you can find equilibrium of charge. This is the case. Three similar charges, capital Q1, small q, and Q2 are placed. There must be similar charges, so the system can be in equilibrium. F1 will be equal to F2, that will be equal to this one. And this charge will be in stable equilibrium. The value of x1 and x2 can be calculated in any way, and you can get this answer. Remember this answer. Three similar charges, equilibrium condition. These are the equilibrium of three similar charges. I'll give you 2 minutes to note this down.